if I have two sides of a triangle, I'm going to use Pythagoras to do that. Now, the other thing we can use with triangles, though, is we can use angles. So when do we use this trigonometry? We use trigonometry. I'm going to use the word trig just to shorthand it. So we use trig whenever angle, should retype that. We use trig whenever angles and right triangles are involved. Make that. So I use Pythagoras when it's only sides of a triangle. I use trigonometry when there's an angle that's involved with it. And so if you guys, should I let you write that down? So if you guys look at your calculators, we know where the tangent button is, but beside that, you're going to see two other buttons. There's SIN. It's looked like it's sin. It's actually sine, and we have COS. That's cos. So we have actually three different one of these. We've looked at tan quite extensively, tangent, but we also have sine and we have cosine here. So we have three of them here that we've used. And so there's a certain order to all this. We know that tangent is opposite over adjacent, right? It's just a rule with that. These also have rules. So I told you at the start of the year that when you come into school, there's going to be two things that are going to be burned into your brain. This is one of them. This little phrase right here, SOHCAHTOA. This is how you remember which of these three am I going to use. So it's kind of split up like this. So I'm going to go to the last one here first, this T. That stands for tangent, and we know that tangent is opposite opposite O divided by adjacent A. So the order you see it in there, the order you see it written is how you use it. So let's kind of go into that first one here. So I'm just going to label these 1, 2, and 3. So this first one here, SOH, so it's SOHCAHTOA. The whole thing's SOHCAHTOA. Like I said, you're gonna have to memorize that. So SOH, the S stands for sine. So I'm gonna put a little 1 there actually, just show that this is 1. So the S stands for sine, SIN. And just like with the tangent that we looked at all the way back in Unit 1, we also have this thing. And remember what this is called, this little circle? Oh, this thing's called theta. And it basically means the angle. So when we see this little circle with the line in it, this is technically called theta. But that also means it is the angle. So this is the angle. So you see that little thing, that means it's the angle. So the sine of the angle of theta is equal to, and I'm looking up at my phrase here, right? SOH, I see O first. So opposite. And I see H, which it stands for hypotenuse. So the first skill we kind of need with this is we need to be able to label triangles. We have that skill. We've done that before. We know how to label hypotenuse. We know how to label opposite. We know that the adjacent is the last thing that's remaining. So the first one is identifying what side of a triangle is what. The second one here is being able to remember the SOHCAHTOA thing. So that's the first one. So sine of theta is equal to opposite over hypotenuse. O divided by H. This next one here, CAH. So it's the ca part. The C stands for cosine. And just like before, cosine of the angle is equal to, so it's cosine of the angle, and that's equal to, I see A is first, so it's going to be adjacent. Adjacent. Yeah. And then the H is hypotenuse, as we know. So that's the ka part. And then finally, this third one here does not really need an introduction. We've used that before. It's TOA, so SOHCAHTOA, that's TOA. Well, I know that T stands for tangent. We know that it's the theta, and we know the O stands for opposite, and the A stands for adjacent. So tangent of theta is equal to opposite over adjacent. That is not new to us. We have seen that before. So I just handed you out a sheet here, and you're going to notice that. Does everyone have that down, by the way? Drink water really quick. Okay. So you're going to notice that I just gave you a sheet that looks like this. So we're going to use this new skill this new information that we have over here. We're just doing just this one page today, and we're going to start identifying some of this stuff. So part of what we need to do is we need to learn how to, you're going to be going back and forth between the two pages, by the way, so please have both available. We're going to need to learn how to identify and set ourselves up for success, because a lot of the math we're doing now is just what's the formula, plug the numbers in and solve it, but you have to figure out like, whoa, which formula it is. So you're going to notice here that you have a whole bunch of triangles, and we're going to be looking at both sine, cosine, and tangent, because we set the triangle up in different ways. But what we use trigonometry for is to find angles. Whenever we have angles involved, we're going to use trigonometry. So for this first one here, so I want to find the sine of C. Now my question for you is, I'm just going to zoom in. Which one of these is C? This one. So this is C. So it wants me to find sine of C. Oh, sine, that's trigonometry. That means it wants me to find the angle here. So I'm just going to quickly mark that in. Oh, that's too big of a, oops. There we go. So I'm just going to quickly mark that in. So this is saying I want us to find this angle right here. It wants to find the length of that angle. So the first thing I need to do, I'm just going to go back to my other page. I'm going to write our steps out. So I'm going to make this a little bit small. Actually, no, I'm going to go down here and do it so I can make it a little bit bigger for you. You can write it up beside that triangle if you want. But so the first thing we have to do, so step one is we just need to, just like before, we need to label the triangle. And that means the angle, but that also means which side is what. Yeah, like which side's like which side is what do you call it? Like opposite and hypotenuse and stuff like that. Okay, so the first thing we need to do, the first step is we are going to label this triangle. So I'm just going to go back to that next sheet here. Like I said, we are going to be going back and forth a little bit. So let's go to this first question here and let's label the triangle. So which of these numbers, 29, 20, or 21, is my hypotenuse? Hypotenuse is 29 because it's opposite of my right angle, right? So I'm going to label that with an H. Now, which one of these is going to be my opposite? It's 21 because it's opposite of the angle that I'm trying to find. So opposite. And then finally, my last side has to be adjacent, right? Adjacent's always whatever you got left. So the first step I do is I just label my triangle. This is not new to us, just a quick refresher. So the next thing we have to do is we need to figure out what we call this like a trig ratio. Those three things up there are trig ratios. Which formula do we use? Now, in this case, it tells us what to use. Yes, this will come in handy. We'll eventually identify this, but the second step is we do figure out what ratio it is. Which of those trigs? Is it sine, cosine, or tangent? In this case, it tells us what to do. So which sign do I use? Oh, well, it tells me already. We'll come back to that step later, but yeah. So just I need to use sine. So I can immediately move to my third step, which is just write the formula down. Right? It's write the formula down. And then it's just fill in the blanks and solve it. And again, your calculator can do all the heavy lifting here for you. In fact, you will not be able to calculate this without a calculator.
Hey, Matt, did we get with 3 decimal points?
I'll get to that. I'll get to that. Okay, so I'll give you just a couple seconds. All right, so we have most of the writing done here. We're just gonna practice these skills now. So I'm going back to this sheet here. So I've labeled it. So now what I need to do is I know I need to use sine. What's my again? We use SOHCAHTOA. I'm just gonna write that up here because I'm gonna reference it a lot. SOHCAHTOA, I know that sine is opposite and over hypotenuse, right? Because that's what it says. So I'm just gonna write that in really quickly. So sine of the angle is equal to O over H. So now that's my third step is I have put in my blank formula here. My final step was I need to substitute stuff. So I don't know what the angle is. So I'm just going to write it in, carry it down here, unless I have something to swap in for it. So the sine of the angle is equal to, I know what my opposite side is. My opposite side is 21. I know what my hypotenuse is. My hypotenuse is 29.
So do you go with the -1 with this one?
I will. We will go over that in just a second here. So I just want to make sure I have the right number here because I need 2 different calculators right now. So I've substituted. That's step 4, and now I just need to solve it. Now, so just like before here, I don't care what the sine of the angle is. My whole goal here is it wants me to figure out what the angle is, right? And there's something attached to that angle. Right now, what's attached to that angle? It is this big sine thing. I need to get rid of this. It's sine times the angle. I have to do the opposite, which is divided by sine. But if you take this fraction and if you divide it by sine, just like before, you break your calculator, right? Your calculator doesn't know how to process that. So we have to speak in a language your calculator understands, which is, it's actually going to be this little -1 up there, right? Second function sine. To get that, you use second function. That's the top left. And you press sine. And you know you've done it right when you see that little -1 there. And I'll show you another way that you know you've done it right after this. But so I'm just going to put that in. So I'm going to take this is what's called the inverse. I'm taking the inverse, that sine to the -1. That's the inverse. So what did I say? That's 21 over 29. So 21 over 29. And I can see I get 46 point, I'll just say, well, technically it rounds up to 0.40. So 46.4 degrees. So 46.4 degrees. That's what the angle is. Now, you're going to know if you've kind of goofed up a little bit. What happens if I don't take this little, like this inverse? What happens if I don't have that little -1 there? You get a different degree. What was it? 21 over 29? You get a really small number, right? If you put this in your calculator and you see like, whoa, it was a 0 point something, you're probably not finding an angle that small. More realistically, you probably forgot to take the inverse. So that's a way that you can kind of know that, oh, something's not right here. We don't just blindly trust our calculator. Sometimes we do it. We use the calculator wrong. Yeah.
Is that the same with cosine, second function?
Yes. Yeah. So let's try another one here. We'll make this one a lot quicker. Let's go straight to question 2 here. So my first step is I need to label my triangle. So first off, what angle am I trying to find? C. So that's this one here. I'm putting this little curve here to show that. You can put the theta in there as well. That works. So this is the angle I'm trying to find. So which number is my hypotenuse? 50, because it's opposite of my right angle. Which number is my opposite? The 30, because it's opposite of my angle I'm finding. And then the last side has to be adjacent. So cool, I've labeled it. Step 2, let's identify what ratio I need to use. It tells me you're using sine. Use sine. So we're immediately going into step 3, which is write our formula down. Now, sine, remember, SOHCAHTOA, the S is O and over H. So the sine of the angle, oh, that's a bad theta. So sine of the angle is equal to opposite O over H. Again, it's really important we understand how I know which formula I need to use, and we use that SOHCAHTOA as a trick for it. Like I said, that is one of the 2 things that will be burned into your brain by the end of the year. So sine of the angle is equal to opposite over adjacent. Now all I do is I substitute the stuff in, right? Step 4, substitute and solve. So sine of the angle is equal to opposite 30 divided by hypotenuse, which is 50. And then I don't care about what sine of the angle is. I care what the angle is. So I need to get rid of this sine. I need to divide by sine, but that breaks my calculator. So instead, we use the second function. So second function, sine, then put your fraction in, 30 over 50. And if I do that, I can see I get a nice easy degree, 36.87 degrees. Oops. Circle that, that's my final answer.
open that up on the next page, when it how it says, the nearest 10,000, is that, 5 decimal points?
That would be 4 technically, but you could just do to 2. Like we're not following the directions exactly how they are up here. You could just do to 2 decimal points. So we solve these other two the same way. We've already solved tangent. Tangent are solved the exact same way, right? Cosine we do the exact same way. So if I want to find cosine of C, I know it's going to be this angle right here because it has the big C beside it. So going to quickly label my triangle. At this point, we probably should have that. 39 is opposite of my right angle. So that means that that's going to be my hypotenuse. 15 is opposite of my angle. So that means that one should be your opposite. And then the last thing's adjacent. Again, we eventually get pretty rapid fire at this. That's step 1. Step 2, identify which ratio. It's telling me to use cosine. So I immediately go into step 3, which is write my blank formula in. So SOHCAHTOA, what would be my formula for cosine? Adjacent over hypotenuse, right? SOHCAHTOA, CAH, adjacent over hypotenuse. So cosine of the angle is equal to adjacent, all divided by hypotenuse. So that's step 3. Now step 4 is I just need to substitute. So what goes in place of my A? 36. And I know that the 39 was my hypotenuse. And so again, just like before, I care about what the angle is, not what the cosine is. So I need to divide by cosine, but just like before, it's going to break your calculator if you do that. If I take 36 over 39 and I divide the whole thing by cosine, it's going to break it. So I use, just like before, that second function. Second function of cosine, and then you put your fraction in there. And you'll get a more proper angle. So 22.62 degrees. And so there's 3 more questions here in this first part. There's one more cosine, there's one more tangent. I'm going to give you guys about 3 minutes there just to try those out. And I'm going to call on someone at random based on the wheel to help me out with it. So I'll give you a minute or 2 to try out these 3 questions as best you can. If you're not sure, please ask for help because we're going to extend this a little bit. Again, I'll just give you about 30 more seconds there just to punch those in. I promise you we're doing this for a reason. Okay. So I'm just going down to these next few here. You're going to notice these questions are a little bit different. It's asking us to find the side of a triangle. Well, if I'm finding the side, don't I use Pythagoras? No, because so now what we need to do is, so remember when I said the second step is like what trig ratio and like figuring out what the formula is, that's when this comes into play. So just because we're trying to find the side, and this is where people always get confused, just because I'm trying to find the side does not mean I'm using Pythagoras. What do I know about question 13? You know the angle. I know an angle and I know the side. So yeah, there's not hypotenuse, yeah, but I have an angle and I have a side. So the second there's an angle involved with it, that's when I go to trig. It's not just because I'm trying to find a side that I use Pythagoras, it's because I'm using an angle that I need to use trig. So the second you get two of anything, if you have two of anything, you can always find something else on the triangle. It can be two sides, it can be two angles, it can be an angle and a side. As long as we have two of anything between Pythagoras and trigonometry, we can always find a third thing in a triangle. The tricky part is identifying, well, which of my two tools do I use? So that's kind of where we're going into now with this. So we still solve this the same way. I'm still going to label this triangle. The 17 is still my hypotenuse. I have an angle here, this 59 degrees, which means this x is still my opposite. And that means that this is still, whatever's left is an adjacent. So we solve this the same way, which is you label your triangle. So I've quickly done that. Now the part is, well, what trig ratio do I use? Which two sides here have something attached to it? Well, so one second. So the 17 here, I can see that, well, that has something. Like the hypotenuse has a number. I can use a number there. And then the other one here is, well, this has an x. This is what I'm trying to find. So I don't care about adjacent right now. I only need those two, O and H. And so if you think about, again, a lot of people do this when they first start learning it, is they write it down on the top of their page. SOHCAHTOA, which one of these two has the O and the H? Sine. So I can see that sine here has the O and that's the H. And now that's how I know that's what I want to use. I look at the letters of it and I'm like, oh, that has O and H. I'll use that. If I have opposite and adjacent, which of those ratios do I use? If I have opposite and adjacent, which one do I use? Tan, because tangent is the one that has the opposite and the adjacent in it. Yeah. If I have adjacent and hypotenuse, I use cosine because that's the one that has the two of them. So I hope that makes some sense. Is look at what's attached, look at like what's attached to the sides of your triangle, and oh, that's what I need to use. So I know I need to use sine. So that is step 2. Step 2 is I've identified what trig ratio. And then it's just the same as before. Now I still write my formula down. Sine of theta is equal to opposite over adjacent. So I still do step 3 the same. And I still do step 4 kind of the same, which is I still need to substitute stuff in. So I'm going to do that. Only in this case, do I know what the angle is? I do. So I'm going to put sine of 59 in here. 59 degrees. It's really important to put that degrees in there. It's really helpful to keep that organized in our head. So sine of 59 degrees, do I know what my opposite is? No. So, but I know it's what I'm trying to find. So I'm just going to put X there. You could leave it as O as well. You could do that. I recommend X though. Oh, sorry, not O over A, it's O over H. Sorry. So I just erased that. And do I know what my hypotenuse is? 17. So all of a sudden, what I now see is this is turned into an algebra problem. At the end of the day, what do I want to know here? What am I trying to find about this triangle? I'm trying to find X, right? So what I want is I eventually want it to be like, hey, X is equal to some random number, right? That's what the goal of this entire equation is going to be. Just like up top, hey, the angle is this many degrees. I want it to tell me the length now. So my goal is I want to just get X by itself. What's the problem with that? What's in the way? Well, what's attached to the X right now? Like I'm looking at this line right here specifically. Yeah, the 17's the issue, right? X isn't by itself. X is stuck with this 17. So I need to get rid of that 17. So how do I do that? So right now, X is being divided by 17. I got to do the opposite to both sides, right? So what's the opposite of dividing by 17? Yeah, just times both sides by 17. So all I'm going to do is I'm going to times both sides by 17. What's going to happen? Well, this on this right side here, those are going to cancel out. So that divided by 17 and that times 17, they're gone. They've just killed each other. So now I've done it. I've met my goal. X is by itself. And now what do I have on this left side here? I'm going to have 1 second. Yeah, so so this left side, so what did I have on this left side? I had well, I'll use red here. I had sine of, the brackets are really important here, sine of 59 degrees, right? So I'm just bringing that down exactly like how it was. But now what am I also doing along that way? Well, I take this route down, it's being times by 17. But so now I've done it. So now all I need to do is punch that left side directly in my calculator as we see it. Sine of bracket, use your brackets. So I'm taking sine of 59. I'm going to close that bracket. It's very important that you have the bracket there, times 17. And if I do that, all of a sudden I can see that I'm going to get 14.57. And that's the length of my missing side. Normally there's like a centimeter or inches or something. This sheet doesn't have that, but so it's 14.57. Now, if you had not closed that bracket, you'd get something like this. The sine of 59 times 17, it's going to break it. You can't have a negative like side, right? Like that doesn't really work. The other thing as well is I did not do my second function this time. I did not take the second function of it. That's a really common mistake that people would make. But in this case, your calculator doesn't know how to process that. So there's a nice fail safe that's kind of caught in there. Now, I will say this. So this sine of 59 degrees times 17, there's a different way you can write this. You're going to encounter both. So I'm just going to kind of show it to you. The other thing we kind of see sometimes is we'll see something like this. 17 sine of 59. This means the same thing. There is a little invisible time symbol there. So this is the exact same thing as sine of 59 degrees times 17. If you put that in your calculator, just like that, 17 sine of 59, you're going to see you get the exact same answer. So you're going to occasionally see the two different formats. You can do whichever works for you, but we need to understand that that is the same thing. So this is where it gets confusing for most people. Because, well, how do I know whether I use that second function or not? And so this is where I'm going to kind of introduce a little bit of a fifth rule into our old sheet. So I'm just going to go back to our old sheet here. I'm going to introduce kind of like a fifth step. Specifically, though, it's going to be I'm going to have step 5A. There's going to be a step 5A and a step 5B. So I'm just going to go with my old sheet again. Again, when I was going up here, when I am trying to find the angle of something, to find the angle, I use the inverse. For example, that's that tangent of -1. So I'm introducing you a new word. We're going to be using a lot, the inverse. So if I'm using the angle, I'm using that inverse thing to figure out what that angle is, right? So it's tangent to the power of -1 of like 5/7 or something like that. But if I go back to what we just worked on, when I'm trying to find a side, so to find a side, I do not use the inverse because I already know what the angle is. So I would just use regular good old-fashioned tan. Good old-fashioned tan. Okay. So we set it up the same way. The difference is what are we trying to find, which changes how we solve it. So what I'll do is I'll give you a couple minutes here. 1, 2, 3, 4, 5. I'll give you like 5 minutes here to try out some of these questions. I'm going to come walk around in a minute to see how we're doing. So I'll give you 5 minutes here. Try out questions 14, 15, 16, 17, and 18. Step 5B was if we want to use a side, we do not use the inverse. So 5 minutes, try out those next 5 questions. But again, just to make sure we're on the right track, I'm just going to do question 15 here. So again, my first step always is, label my triangle. This is 20 is my hypotenuse. The blank side's my opposite. And the one with the X is my adjacent. I like circling. I look for the 2 things that have something beside it. I like circling it. You don't have to do that. I think it's a really helpful tool when you're first learning. But what am I looking at? I'm looking for an H and an A. SOHCAHTOA. H and A is cosine. So I just write my blank formula. Cosine of the angle is equal to, so it's ca, so it's A over H. Now I substitute in. So in this case, the angle I know is 27 degrees. My adjacent side is X. And my hypotenuse is 20. So now what I have to do is I have to get X by itself, which means I need to do the opposite of what's happening to it. X is being divided by 20. So I need to do the opposite, which is timesing by 20. And so what I'm eventually going to get here is I'm going to get cos of 27 times 20 is going to be equal to just x, because these two things cancel each other out. And then what actually is the answer for that? 17.8. So if you punch in your calculator, you get 17.8 degrees. So
were we just going through one decimal point or two?
Sorry.
Says it's.
Oh yeah. Either's fine right now. I care more that we can actually like do all the hard stuff instead of the rounding. This one isn't my sheet. I borrowed this from a different teacher just because I liked it. I liked that it was compact. So normally I like going to 2 decimal points, but yeah, you would lose no marks if you rounded it to 1 or 2 or 4 or whatever, like because you've done the hard parts. So what we're going to do is we'll take our break now. When we come back, we're going to try some of these ones here. Specifically, actually, before you go to your break though, was it 22? Evan, was it 22 we were looking at? Or which ones was it?
The hard one.
Yeah, the one that 2-step one.
Yeah.
Oh, 16 and 17. Okay. Okay, yeah. So we're not doing those two. If you were struggling with those, we'll deal with those two tomorrow. That's a 2-step equation. I don't want to throw the world at you all in one day. So we'll go for our break here. We'll give you your 15 minutes. When we come back, we'll kind of put a nice little bow on top of this. Okay, so what we're just going to kind of do here for the last little bit, I'm just going to quickly go over one of these ones, questions 19 to 24. This is actually something that we've seen before. Here we're finding the angle. This is exactly like what we had done all the way at the very, very start of the class. The only difference here is before at the start, you were told what to find. With this one here, you don't actually know what to find. You don't know which ratio to use. So I'm just going to do one. At this point, I think we're pretty equipped to be able to do this. But just as a quick example here, I still solve it all the same way. I'm going to label my triangle. 44 is my hypotenuse. 39 is my opposite. And this leftover side is my adjacent. I'm going to figure out which ratio I have. So if I have an O and an H here, which ratio do I use? Sine. I know I'm going to use sine here because it has the O and the H. So that's the only real difference here is you just need to identify which one of those 3 ratios. Holding back sneeze again. Yep. Yes. The second there's angles, like I need to use trig. Yeah. If I asked you to figure out what the length of that side was, yes, because you're only using sides. The second there's an angle involved, even if I know what the angle is, there's still an angle involved. That's when I use trig.
Okay, follow-up question. What if it gives us the information given us, or maybe not the information, say it gives us an angle on one side, and then tells us to kind of say the hypotenuse if we don't have that. Right? But would we do trigonometry and switch that to hypotenuse after? You
would still use trigonometry, yeah. Yeah, you can always figure out what side you want, basically. No. So the second there's an angle, it's only going to be trig. There will be some times where we need to do that, but that's later on. Like that's going to be like you'll see it in the booklet later.
And those
sorry.
I'm assuming those probably wouldn't be common. Switch it.
And it'll come later. It'll make more sense once you see it. But like when we're dealing with a single triangle, you just pick one. But when you're dealing with multiple triangles, like sometimes I might need to use a trigonometry to find a side of a triangle so that I can use that with another triangle to find like the hypotenuse. But that will make more sense once we see it. Like you'll see. Yeah. But right now, if I only have one triangle and I have an angle, I need to use trig. So I know I identified I need to use opposite and hypotenuse here. So that means it's sine. So you could put the question mark in here if you want. You could put X. I recommend put the theta symbol because that way it's gonna embed itself in your brain and you'll recognize what that is in 2 months. Because remember, you're gonna get like 3 weeks off during the break. So I want to make sure that we have this implanted in our head. So sine of theta, the angle is equal to opposite over hypotenuse. So the sine of, I don't know what the angle is. My opposite, however, is 39. My hypotenuse is 44. All of a sudden, oh, this is exactly what we saw at the start. I need to get rid of the sine, which means I need to use the inverse. Remember that inverse is that little -1 there. I'm finding an angle. That means I need to use that second function. So it's second function sine of 39 over 44. All of a sudden I see it's 62.42 degrees. And again, I don't really care how you round it right now. I will not take off marks if you round it to, like, maybe you round it to 62, maybe to 62.4. Maybe you have this. I don't care. What I care about is that you were able to do all this hard stuff up here right now. The rounding will not be important right now. So it's exactly what we did at the very start, except we're just identifying which of the ratios we use. Otherwise, it's the exact same. So with that said, I'm going to let you guys kind of carry on through this sheet here. There will be 1 or 2 of these questions that we're not fully equipped with yet. It's called a 2-step one. It was just like these 2 questions, 16 and 17. There's a reason we didn't do them. We will come back to that later, but we don't need to worry about that today. So I'll give you the rest of the class here to kind of do some stuff. I'm going to come around in about 5 minutes to see how we're doing. Quick reminder, tomorrow, we are going to have a concept check for all of Unit 3, so the volumes and surface areas. We will go over your old concept checks as well. We were going to do that today, but I didn't press record, so I don't have the video, so I have to do that again. So just so that's not a surprise for you. So really quick reminder, tomorrow we will be doing the concept check. But for now, I'll let you guys get onto this, and I will come around in 5 minutes and see how we're doing.